So the sixth adaptation of how the finned fish are going to be locomoting in water is that they possess a swim bladder. We call it actually a swim bladder. And what is the importance of the swim bladder? It helps the fish in creating what we call buoyancy, and also helps the fish to adjust its vertical position in relation to depth in water. So what do we mean by this? We're saying that the fish, because it is swimming in water and there is that different depth of the water in terms of how they're going to be swimming, so they possess a swim bladder so that they can be able to create the buoyancy. And what do we mean by the buoyancy? Buoyancy is the ability of the fish to float on water. When you look at the water that the fish lives in, you'll realize that the fish is always swimming in water, and that water is found at different depths. There are instances whereby as the fish swims in the water, there are places whereby it is raised, there are places which are very deep inside the water. So as the fish swims, it needs to adjust to the different depths of the water inside the either the ocean, the lake. So that is the reason as to why it has what we call the swim bladder, that helps it in creating buoyancy and also helps it in adjusting to the vertical position in relation to the depth of water. So that is the sixth adaptation of how the fish is going to be adapting to its mechanism of swimming in water. Now, what happens in terms of this in terms of the swim bladder when it is filled with air? Because a swim bladder, it is just an open bag that is always filled with air. So when it is filled with air, what is always happening in terms of creating the buoyancy is that it is going to lower the relative density of the fish in relation to the relative density of the water, so that the fish can occupy the higher levels of the water. The density of the water is going to be high. The density of the fish, because of the air that is found inside the swim bladder, is going to have a low relative density. So that low relative density makes the fish to actually be on the upper surface of the water when the fish is swimming. Then when the fish approaches a deeper end, the relative density of the swim bladder is going to be higher than that of the water. Hence, it is going to swim deep inside the water. Now, this fish, when it is swimming in water, there is the presence of other creatures or other animals which act as predators to the fish in terms of feeding on the fish. So what happens is that the fish possesses a lateral line, and this lateral line along the body of the fish enables the fish to detect vibrations. These vibrations are going to be found inside the waves and currents in the water, and it changes and the changes of pressure in water, thus enabling the fish to respond suitably. So if a fish is swimming from this direction, going towards this direction, and there is a predator that is approaching from a distance, the fish will be able to detect the presence of the predator in terms of vibrations, and the changes in pressure inside the water. So what happens? The fish will be able to either change the direction of swimming, or it's either going to move up above next to the water surface, or it's going to swim deep inside the water so that it can be able to escape the predators. So that is the reason as to why it possesses a lateral line, to be able to detect the vibrations and change direction in terms of escaping the predators. Maybe there is an obstacle in terms of the path that it follows. So that is the reason as to why it's going to have the lateral line, so that it escapes the danger ahead of it. The eighth adaptation of how this finned fish is going to be adapting to the modes of locomotion is that there is the presence of the fins. And earlier on, I had mentioned something about the fins. A fish has two types of fins. There is the paired fins and unpaired fins. The paired fins are two. We have the pelvic fin, which is an example of a paired fin, and the presence of the pectoral fins, which is another paired fin. Then we have three types of unpaired fins. That is the anal fin, which is an example of unpaired fin. There is the caudal fin, or what you call the tail fin, which is an example of unpaired fin. Then on top of the fish, there is what we call the dorsal fin, which runs from almost next to the tail fin towards the inflexible head, which we had earlier on mentioned. So that is what we call the dorsal fin, which is an example of unpaired fins. So what do these fins do? And what is the importance of the fins? Fins help the fish in movement through the water. It helps the fish in terms of the movements in water, because the fish is swimming and does not possess what you call the limbs. For instance, in mammals, like human beings, we have both what you call the forelimbs and the hind limbs. The hind limbs are modified to form what you call the legs. The forelimbs are modified to form what you call the hands. So these hands and legs are used for locomotion and support. But the fish is going to be using the fins when it wants to move either forward, sideways, when it wants to change direction. That is the reason as to why we're talking about the fins. And these fins, they're also going to help the fish, to maintain balance, because as the fish swims, it needs to swim in a particular direction. It doesn't swim as it moves from side or line side and the other side, what you call the yawing. So it needs to maintain the balance. It also needs to steer the fish and to bring about swimming. To steer means to make the fish move in a forward direction. So that is the reason as to why the fish possesses the fins. It helps the fish in maintaining balance and also to steer the fish and to bring about the swimming process. That is the importance of the fins in a fish.
Yes, fine.